Newton, and eventually Einstein. So when we say gravity is the curvature of space-time, or the result of the curvature of space-time, that's not a definition. That's a way of expressing a scientific theory. We have lots of those in physics, we have them in chemistry. Plate tectonics is an example of a scientific theory that helps us understand things. We don't have that at all for life.
I will channel my Star Trek theme here and say, as we seek out new life and new civilizations, whatever that might look like in the universe, you've written that the focus is very often around Goldilocks planets. Can you explain that?
Yeah, so when we are looking at planets around other stars, there's a lot to learn. And we have found them to be much weirder and more diverse than we expected. Other solar systems don't tend to look very much like ours. But when we're looking for planets that could be home to life, from how we understand it, it's a reasonable assumption to say that life elsewhere, just as it does on Earth, may require liquid water. So planets in the Goldilocks zone around their star are the right distance from their star so that they're not too hot, not too cold, not too close to the star so that all the water gets boiled off, not too far away that it's all frozen.
But here's where I get, the uninformed mind in me looks at water and heat and says, why does it have to be that? Like, why could life not exist in a completely different way? In the same way, and again, I'm going to over-channel Star Trek here, that sometimes you moved away from humanoid actors and it was just a cloud in space and they realized that was life, or that artificial intelligence was potentially life itself. Why could life not exist without water, without heat? Why are we so fixated on that?
We're fixated on that not because we think that that's the only way that life could be, but that is the one way that we actually do know life could be. And we need to start the search somewhere. We have barely scratched the surface in our search for life. And we know that on Earth, water is very important, carbon is very important. And it's not just, oh, that's how it happens to be on Earth. Both water and carbon have very specific properties that make them extremely useful. Carbon can be the backbone of very long, complex molecules, and it forms bonds very easily with itself to create long chains. And water is a fantastic solvent and has this very rare property where its solid form is less dense than its liquid, which we know in daily life as the fact that ice floats. So that's really important for life. I mean, life began in the ocean. Oceans, lakes, and water are such rich places for life to be, and if ice didn't float,